Hello, everyone. Thank you for joining us in our session today on multidimensional scaling with Couchbase and Kubernetes. I'm Anil Kumar. I'm a senior product manager at Couchbase. I'm responsible for our flagship product, Couchbase Server, and also building our ecosystem for Couchbase. So I work with the strategic partners such as CoreOS in building a joint value proposition for enterprise customers. Along with me is Hoang. He's a developer advocate on the Couchbase Server, Couchbase Mobile, and Sync Gateway, and he's based off in New York. Right. So before I get started with my presentation today, I would like to do a quick poll to understand how many of you here already know about Couchbase. Can you raise your hands? Cool. All right, thank you. So there's few folks who don't know about the Couchbase. I'm going to spend a few minutes talking about the just quick overview of Couchbase, and then I'll go into our topic today, which is Couchbase with containers. Find the. Oh, sorry. Is this the?
Yep, it's this one.
Okay.
Green.
Next one. Good. Thank you. All right. So as you can see, we have a lot to cover today. And we have very limited time, which is 25 minutes. So I'm going to be. Sorry. So I'll quickly start with the overview of Couchbase. So Couchbase is one of the top 3 leaders in NoSQL databases. And you might know the other 2 databases, which are the Cassandra and MongoDB. Couchbase technology can be used in many ways. And customer uses for many reasons. And it's one single technology, but it can be used for many other reasons, such as they use it for managed cache, which is just to speed up their other databases, which is like relational databases. In this case, it's only it acts as an in-memory database. There's no persistence. So the Couchbase can be also used as a key value store, also as a full-fledged document database. We support JSON documents natively in Couchbase. Also, we recently released our own query language. It's called Nickel, N1QL. And it's a SQL-like query language, which works on the JSON documents. I would really encourage you to check it out. The reason is, if you have ever used SQL language, you would write the same exact SQL statement, which will work on the JSON documents. And so Couchbase is also is the first and has the only solution on the mobile. So we have a lighter version of Couchbase, which runs on the mobile devices on iOS and Android. And also we have this sync technology, which is awesome which basically synchronizes all the data from the connected devices back to the cloud. So here are some of the top use cases of Couchbase where customers see us fit for their mission-critical applications, such as profile management, the high availability caching, mobile application, Internet of Things, real-time big data, and so on, right? So in terms of numbers, we are like 300 plus employees. We have 500 plus enterprise customers, and also we are 100% open source, Apache 2.0 public license. So I don't want to spend more time on the Couchbase because we have not much time here. So I would encourage you guys to take a look at couchbase.com. So now the topic why we are here, which is Couchbase with containers. So what are we doing here? So some of our existing customers, enterprise customers, and I have just listed 3 of them here, the Citibank, Kodiak Network, and Comcast. Some of our existing customers now have started investigating on the containers, and they want us to make the containers as a first-class citizen, right? Fully supported. And when I talk to them, what they want to do is a phased approach. The phase 1, they want to basically replace their entire development and test infrastructure to the container technology so that it becomes easier for them to deploy, portability, and also main thing is cost benefit. In the phase 2, they will have more data in terms of performance, benchmark, and everything, and then they can make a decision to go to the production, right? So this basically what they're doing is phased approach. And here are some of the deployment strategies they have is like they want to deploy the Couchbase server as a cluster of containers along with their the middle tier and the front tier. And they want to, if they have a use case for mobile, they would also want to have container for Couchbase server with Couchbase mobile in the same container, or it could be a separate container. And also, along with that is the auto-scalability, which is like you can add containers easily, and depending on the need for capacity, you can automatically add more containers. And manage and monitor all the container with a single cluster manager. That's what the deployment strategy is. And we'll cover more of the deployment strategy in the remaining part of the discussion. So the next topic is the brief history of scaling in database. And you might be thinking is like, why would I bring up the history of scaling in database here? The reason is like there are some challenges we are trying to solve in the database space, and which we believe is similar to what you guys have been solving in the virtualization field. So the idea here is like, so there are some disruptive technologies which came up in the virtualization, which is like hardware level virtualization. There was platform level virtualization, and now we have this OS level virtualization. And the container was what the new term disruptive technology is, right? So this is the securely isolated and virtualized by a single operating system. So we had similar challenges in terms of in the database space, which is related to the scalability. There are different aspects of the aspects in the database, such as scalability, availability, but all of them are tightly coupled together. So in database, we had challenges in terms of scalability. We had only one architecture in the past. This scale-up architecture has been prominent for the last 30 years. And all the relational databases are still with the scale-up architecture. What you have in the scale-up architecture is a single monolithic server, and pretty much all your workload is on the single node, on single monolithic server. If you want to add more capacity, if you want to make your data access faster, if you want to make your queries run faster, all you need to do is like add more CPUs, add more RAM, or faster SSDs to the single monolithic server. That's how you basically add more capacity or make it more performant. One good thing about the scale-up architecture is because all the workloads is on the single monolithic server, there's no network dependency, right? So there are some good things about the scale-up architecture, such as because there's no network dependency, and nowadays you get the hardware which are much more beefier, 24 core, 46 cores, 1 terabyte RAM, and the faster SSDs and all. But again, on the contrary, there are a lot of other negative things, which is like they are very expensive and also requires downtime. When you want to upgrade your hardware, you want to change it to the next hardware, you have to basically take the whole database offline and then upgrade it. So your application will have the downtime. Also, this performance is bounded, right? Because when you have a 24 core, you can only get the performance at that speed, right? So beyond that, you have to upgrade it again. So it's basically limited in scalability. It's limited in terms of elasticity. And that gave birth to the new architecture, which was scale-out architecture. The scale-out architecture is what is a modern architecture where pretty much most of this data-related, like NoSQL, big data, pretty much are all on the scale-out architecture. The idea here is like you have a cluster of commodity hardwares, and the data is evenly distributed across all those nodes, commodity hardwares. And if you want to add more capacity, if you want to make your data access faster, if you want to make your queries run faster, all you have to do is add more data, add more commodity hardware to your cluster. That way you can basically increase your capacity. So in this case, there's a network dependency. Because it's distributed and the data is all spread across multiple nodes, there's always a network dependency. So there are a lot of good things about scale-out architecture. In general, it's simple and easily scalable because pretty much like Couchbase is a single node architecture, which is share nothing. In that case, you can add more nodes and easily scale your cluster. So data is also evenly distributed, so it's horizontal scaling. And so as you add more capacity, your throughput will increase linearly along with that, right? So that's the good thing about the scale-out architecture. And also, there's no single point of failure because you can create data redundancy in the same cluster. You can have, once there is a couple of nodes fail, then you can basically fail over to the other node. So it's basically, there's no single point of failure. So one negative thing about the scale-out architecture is, if you come from database background, you would essentially know that there are 3 workloads in database, which is there's a data workload, which is actually data access pattern. There is your data access, which is get and set. And there's the index workload and the query workload. Even though when we say scale-out architecture is the new modern architecture, which is awesome and all, it fits only one for the data workload. if you have a data workload, the scale-out architecture is awesome fit for that, because what it does is, like, as you add more community hardwares, its storage is increasing, its RAM is increasing, so it scales out along with that. But whereas with the other workloads, which is query and index workload, on the other hand, doesn't fit well with the scale-out architecture. And so far, all the databases have been having this challenge, which is like, how do you scale your index and query workload? Because all of them are tightly coupled together in the database, right? So what happens is, like, when you have 100 nodes of cluster, like let's say you have 100 nodes of cluster, and your index is spread across all those 100 nodes. When you issue a query, it has to go and scatter the request to all those nodes and gather the data at one node, compile it, and send the results back. So this scattering and gathering is very complex operation. So in general, the question usually comes to is like, it's what's the right model, right? So do you want to scale up or you want to scale out? So for scaling up, there are some good things about scaling up, but it won't fit well. So the scale out is good for data, but it doesn't fit well for the query and index, right? So we at Couchbase, and again, why we are here is what we started thinking about, and what really matches with what you guys have been doing in the containers is the virtualization or isolating the services. So we started thinking hard, and we designed this new technology called, architecture called MultiDimensional Scaling. It's a hybrid approach, and here's an example, right? So we have, let's say you have deployed your database across these 8 containers. Right now, this is how it looks like, right? So you have all these workloads running on those 8 containers. Because they're running on the same, all the containers, there's each of this service is competing for the same resources, right? Because index workload and the query workload and data, they're all spread across evenly on all the 8 nodes. So if any of the workload, let's say index workload is heavy, it's going to affect your data workload and query workload, right? So that's like eminent here. So that's why we came up with this architecture where we can isolate the service. So we are calling this workload as a service, something similar to what the containers are doing. The idea here is, like, you will have isolation of the services so that they don't interfere with each other. And also, you can have independent containers for query, for index, and for your data service. So that way, you can dedicate those containers for only those services. That way, so let's say if you are having a long-running query, which is going to take long time, it's not affecting your index service, it's not affecting your data service. So that's the beauty of like isolation of the service, right? And that's not it. So what we also wanted to solve is like the scalability, right? So what we did is, I talked about earlier the scale-up and scale-out architecture. And I told the scale-out architecture works well for the data nodes, but not for the for the index and query nodes. We could do this also right now. So what we could do is, like, for the containers for data service, we can add a cheaper commodity, like cheaper container, which doesn't have to have that much of CPUs, like 24-core CPUs or whatever, right? It can have just 4-core CPUs and maybe 16 GB RAM, and it can have a huge storage. So those can go into that containers can go for the data service. For the index as well as query service, it needs a beefier machine. So it doesn't need that much of RAM, it doesn't need at all the storage, but what really it needs is CPU, horsepower, because it has to do a lot of parallel processing, right? So that's where these containers will have much more beefier, like CPU, high CPU containers. So that way we can scale up within the same cluster. Now we can scale out as well as scale up. So that's exactly what multi-dimensional scaling is providing. So now the question, big reason why I'm talking all about this multi-dimensional scaling and containers. The idea here is, like, we think that these two technologies are really marry each other together, right? So they both are complementary to each other. So when we talk about, like, what I really foresee is when the enterprise customer comes to us, and when they look at the architecture, what we have, and what container is providing, I feel like this is like easy buy-off for them. So it's like, oh, this seems like what is a real good fit for us. I mean, that's the faster adoption for the enterprise customers. So we will have a little bit more details about the deployment strategy. I'm going to ask William to come and talk about it.
Thanks, Anil. Yeah. Ooh. Okay, can I get a picture? Because my mom doesn't believe I'm on stage for this. She called me, and I'm like, I'm busy. All right, smile. Thank you. Cool. So deployment strategies. There's actually a lot of different deployment strategies, right? You can go bare metal physical servers, you can do VM virtual machines in the cloud, or you can consider deploying a fully managed solution by your cloud providers, right? But you're here in a container conference, so the question is why even consider deploying Couchbase with your containers, right? So, am I too far from here? So if you think about what's happening right now, is that we're all hyper-connected. There's a lot of users, billions of users on the internet from multiple devices that's being connected. And the hours spent on the internet is quite a lot, right? Averagely speaking, 35 billion hours a month, right? And that's not slowing down. And if you ask yourself, what are the reasons for that? And what's that rapid growth or concurrent data that's being generated? Mobile is a huge, huge opportunity and reason. 1.75 billion mobile devices right now, right? That's pretty scary. It's coming from North America and beyond. And if you think about where mobile is not only consuming these data points, but they're also generating these data points, right? So with that said, currently, if you think about the intent, like let's say you do a mobile check-in, right? One explicit intent, like checking in on Facebook, gets you maybe 10 data points. For example, if you check in here today, you get a lat long, you get a timestamp, you get an actual association like Times Square that's coordinated to this lat long. You get who you're checked in with, and if there's a picture associated with that, that's also attached to it. So you get the idea, but not only that, your solution, your mobile application, and your infrastructure needs to support something that wasn't the case before, is that it's 365 days a year, 7 days a week, and a global user base. And if you look at the problem that's being solved right now, is that the solution to the problem is that this rapid growth on the internet, there's a need for an easier way to scale our databases to meet those demands. And that is what Couchbase solves, right? Couchbase solves not only on the mobile side, but on the server side, this particular problem. If you just look at the trends right now of what these data points are coming in as, these unstructured data points are not slowing down. What's driving this, if you think about it, is this volume of users, this concurrent number of users, and that means more data. When you talk about the IoT movement of your wearables, of your home, in the car, all of that stuff also is attributing to this particular trend. And don't forget cloud computing. So all of that, with all that trend, if you think about how can a traditional relational model fit those demands, if you look at what's currently happening, there's no way for we can scale our databases to meet those demands. Only way to do it is by throwing more hardware at it, right? And that means money, and that's cost. Containers with a NoSQL database technology like Couchbase is that solution for this modern era. So what does containers with NoSQL provide? One is productivity. If you look at productivity, better application development productivity through a more flexible data model, right? So containers with NoSQL also provide scale and dynamically scalability. So if you've been hearing this yesterday and today throughout the conference, how scaling can help, containers can help with scaling. And for example, NoSQL is no different. That complements this particular trend. So you basically have greater ability to scale dynamically overall to support more users and data throughout your application and business logic. Third, performance, right? Improve performance to satisfy expectations, basically allowing your users to have rapid responsive experiences and the application to do more complex processing. So if you think about what NoSQL is for us here, like a document or JSON database, you can just retrieve the entire business object out immediately. There's no other particular language you need to use. If you think about also the first thing when you talk about how to do this, right? For us here, setting up Kubernetes is the first thing before you actually run Couchbase. We're using Google Compute Engine here. And with Kubernetes, for us, what we're doing is this cloud deployment strategy. If you look at it, what it provides is this open source architecture provided by Google. Runs Docker and Rocket containers and runs on-premise or in the cloud. And with the enterprise support of Tectonic, which is the CoreOS and Kubernetes stack, that's also supported. And if you think about the amount of users that's actively behind this project, this is not something that's going dark. So that's very key. There's a lot of technology out there, a lot of reasons why you adopt something or choose something. The power of this would definitely provide you that scalability and multi-dimensional scalability feature altogether. And it's actually quite easy to start. Start your XTCD, run your Couchbase and admin credentials on top of that, in that. We talk about replication controller, so just kick that service off. So that's on the server side. The sync gateway, which is representing the mobile side, is no different. I just outlined this in 3 steps, but there's actually a blog on this topic, so definitely check out the Couchbase developer portal or any blog topics if you like. There's a whole section on this stuff. And speaking about blogs, there's a lot of learning resources, so I want to bring Anil back up and talk about where you can get started and what are some next steps.
Thanks, William. So as William said, there's a lot of content we have on the blogs, as well as we have some good documentation in Couchbase. So also there was a presentation which Brian did in our Couchbase Connect. I have put it up here. So he talked about how Kubernetes, Tectonic, and Couchbase to get together and work as a one solution. So please check it out. So I think we have some time for quick questions, if we have any questions. No questions?
I will actually ask one here. So,
sure.
What would you say has been the biggest challenge in actually the packaging of the Couchbase container and the different components that you need, like the add-on agents and things like that?
So in general, the Couchbase, the packaging as far as the packaging itself is not that much of, we don't have that much of trouble with the packaging stuff. It's mainly the data itself, right? Okay. So when you have data in certain cloud, for example, right? So moving that from one cloud to another cloud, or from one on-premise to another premise. So that is a big challenge for us, right? So one of the requirements of where all of our enterprise customer, they have some use cases where they want to stand up an exact same replica of their cluster on different continent, in a different geographical continent. So in that case, we have to basically package the entire, the configuration stuff. And then along with that, we have to have this mechanism to transport the data also.
And one other question there, would you have any recommendations for other people who need to package their software this way, like best practices that you've found in the process of working through this?
Yes, so one other thing which we, when you introduced Tron, so Tron is one of our engineers in mobile. He's been working, and he's very passionate about containers and all the stuff. So one of the feedback he gave us is the packaging becomes very easy. For example, in fact, the blogs which William has wrote, or even the Arun Gupta, who's our VP, has wrote, it becomes much easier to package the whole stuff. You can auto-configure everything, automate the whole steps. So that whole thing is it takes a few minutes to even set up the whole entire cluster, right? So that becomes super easy for developers or testers who wants to quickly deploy and test out the stuff. Anything you want to add?
And I think.
Oh yeah, you have a mic.
And just to add to that, you get that consistency across all your teams, right? So the key thing is the time deploy decreases, but also all the troubleshooting and back and forth of with your DevOps team, completely experience is up, time is down, and it's just an overall great experience where you can have that overall flat structure across your entire organization, and everyone's on that same config.
Right. And also that we have, as William was talking about, we have Couchbase Server, which is a NoSQL document database, but also I mentioned that we have a mobile solution and also Sync Gateway, right? So if you have a mobile application, then you would have to have the Sync Gateway installed. So there's a separate configuration for that. So packaging all of them together and shipping them for the development, it becomes much easy to deploy and everything.
Fantastic. Cool. Let's get a round of applause for Anil and William.
Sure. Thank you.